Good day, friends, and you are again welcome to another WASE online experience. My name is Philip, and I'll be your instructor for today. But before we start our activity for the day, I'll need you to subscribe to our channel if you've not already done that. Remember, once new videos are created, you'll be sent an alert if you have subscribed to this channel. To be able to do this, you simply need to go below the video and tap the subscribe button. Alright, thank you very much for doing this for us. Let's look at our activity for the day. Today, we will be looking at part 5 of algebraic expressions, and under this part we'll be looking at factorization of algebraic expressions. To start, let's look at the meaning of factorization of algebraic expressions. Let's use the following expression to describe factorization. We have the algebraic expression 2y plus 2m. This expression has two terms. The first term of this expression is 2y, and the second term of this expression is 2m. You realize that these two terms of this expression have something in common. They all have the item 2. So you find 2 in 2y, and you'd also find 2 in 2m. This item 2, which is common to both terms of the expression, is what we call the common factor of the two terms. We can rewrite this algebraic expression in another form, and we can do this by bringing the common item, in this case the common item is 2, outside of a bracket, and leaving the items that are not common within the bracket. So let's look at how we can do this. So in this case, our common item is the number 2. So let's write it outside of the bracket. Then we'll write our uncommon items within the bracket. The items that are not common factors are y and m. So we would write them inside of the bracket. So at this point, we've been able to factorize our algebraic expression into 2, then we have the bracket y plus m, bracket closed. Now I need you to note that we can use the method of distribution to move the new expression back to its original form. So all you need to do is to multiply the 2 to the items, or to the individual items within the bracket. For example, the 2 would multiply the y, and you get 2y. Again, the 2 would multiply the positive m, and you get positive 2m. So you see, we have gone back to the original expression given to us. So if you do this and you do not get the original expression, what it means is that there is a problem with your factorization. So you really need to check if your distribution does not take you back to your original expression. So if we are asked to define factorization, we can say that it is the process by which we can break down an algebraic expression into smaller quantities called factors that can also be multiplied together to give the original algebraic expression. As simple as that. Let's factorize another algebraic expression. And in this case, we've been given the algebraic expression 2a plus 2a squared. This algebraic expression is another example of a two-term algebraic expression called a binomial expression. And you realize that in the first term, the item 2 and a can be found. Also in the second term, the item 2 and a can also be found. So the item 2a is common to both sides of the two terms. So we can factorize that out. So when we do this, we would get 2a outside of the bracket. So what will be in the bracket? Remember, the 2a of the first term, everything has been taken away outside of the bracket. So there is nothing left. But actually, there is the item 1 left. Whilst in the second term, only 2a was taken out. So you were left with one of the a's. So simply put, we are left with the items 1 plus a within the bracket. So let's write that. So when we factorize the expression 2a plus 2a squared, we would get 2a bracket 1 plus a bracket closed. Let's look at another example. Here we have been given 7a squared plus 14a cubed minus 7a exponent 5. This is an example of a trinomial expression. It is a three-term expression. That is why the term trinomial expression. In this expression, we have the first term to be 7a squared, and the second term is positive 14a cubed, and the third term is negative 7a exponent 5. Now when you pay attention to this expression carefully, you would realize that the common factor 7a squared can be found in each of the terms. For example, when you go to the 14a exponent 3, you can find 7a squared in the 14a cubed. Also, when you go to the negative 7a exponent 5, you can find 7a squared in there. So the common factor is 7a squared. So let's write it outside of the bracket. Now, what items are left inside of the bracket? So after we've taken the 7a squared from the first term, what are we left with? Everything is gone. So we are left with the number 1. With the 14a squared, 14a cubed, 7a squared is gone. So we are left with 2a. Also with the negative 7a exponent 5, 7a squared is gone. So we are left with a exponent 3. So the items that are supposed to be in the bracket are 1 plus 2a minus a exponent 3. So when we factorize the expression above, that is the 7a squared plus 14a cubed minus 7a exponent 5, we would get 7a squared all into bracket 1 plus 2a minus a cubed bracket closed. Now I'll need us to note that depending on the question presented to us, different types of factorization methods would have to be used. So we are going to look at various types of factorization methods that can be used depending on the question that is presented to us. So there are various types of questions. that can be presented to us for us to factorize. We have type 1 questions, where the ones we've just solved, where an algebraic expression is presented to us, and all we need to do is to figure out what the common factors are. Then we put them outside of a bracket, then we put the uncommon items within the bracket. You also have the type 2 questions, where you use what we call the method of grouping. Then we also have the type 3 questions, where you are given quadratic trinomials and you will be expected to factorize them. Then the final type, you are given the type 4 questions, where you have to deal with difference of two squares. So we'll be looking at each type in our next slide. Let's start by looking at type 1 questions, common factors. And I remember I said earlier on that the examples we've looked at earlier on are type 1 questions. So here you're giving an algebraic expression, and all you need to do is to figure out what the common factors are. You bring those common factors outside of the bracket, then you leave the uncommon factors within the bracket. That's all you need to do. So we'll look at 2 examples here, then we'll move on to the next type of question. Let's look at example 1. For this example, we have been given the algebraic expression 5x plus 9x. First, let's note that the expression 5x plus 9x is the same as 5 times x plus 9 times x. From this expansion, you would realize that the item that is common to both terms of this expression is x. So we would bring the x outside of the bracket, then the 5 and the 9, we put them in the bracket. When we do this, we would get x, then our bracket 5 plus 9, bracket closed. Let's look at example 2. In example 2, we have been given the expression 5my plus 5ky, and we are to factorize this expression. This expression in expanded form would be 5 times m times y plus 5 times k times y. Now let's select the items that are common to both terms of this expression and put them outside of the bracket. So the item 5 is common to both terms. Also the item y is common to both terms. So what this means is that we would take the item 5y and we will place it outside of the bracket, and we will leave the items m plus k inside of the bracket. So that would give us 5y bracket m plus k, bracket closed. Let's look at the type 2 questions, method of grouping. With this type, you are usually given an algebraic expression in 4 terms. For example, the algebraic expression x squared minus ax plus bx minus ab. Now for these types of algebraic expressions in 4 terms, when we try to factorize the entire 4 terms, usually we realize that you will not be able to get common factors. So for example, the item given to us right now, when you move through the 4 terms, you will never be able to come up with factors that are in all of the 4 terms. So usually we put the 4 terms into groups of 2. Each of the group would have common factors. So in this case, we'll represent the first group by this green shaded area and the second group by this yellow shaded area. So we'll rewrite the expression again, but this time in these 2 groups. So first we'll write the group green, which is s square minus ax, all in brackets. Let's write the second group, which is the yellow group. That will be positive bx minus ab, all in brackets. Now always remember to bring the sign positive or the plus sign between the 2 groups. So in between the 2 groups we would put the positive sign. Now with our plus sign in between the 2 groups, we would go ahead and factorize them. So we would start by factorizing the green group. When we do this, we would get x, then our bracket x again minus a, bracket closed, then our plus sign. We are factorizing the b group, the yellow group. The common items or the common item is b, so b outside of the bracket, then bracket x minus a, bracket closed. So that's what we are going to get. Now when you observe our new results carefully, you would realize that we have 2 terms now. The first term is the green term and the second term is the yellow term. You would also realize that the first term, the green term, has the factor that is into bracket x minus a, bracket closed, and the second term, which is the yellow term, also has the same factor into bracket x minus a. So what it means that the green and the yellow terms have the same factor x minus a. All of them are in brackets. So let's factorize that out. So write that expression x minus a down. Let's do that. Now also you realize that for each of the groups, the green and the yellow group, they have items that are outside of their bracket. So outside of the bracket of the green group is the item x, and outside of the bracket of the yellow group is the item positive b. So we are going to join those 2 items together to form one factor. So when we join them together, we would get x, which is the green outside, plus b. So let's write x plus b, everything in brackets. So when we factorize the expression x square minus ax plus bx minus ab, we would get the final answer to be all in bracket x minus a times another all in bracket x plus b. Let's look at some examples. Let's look at example 1. In this example, we have been given the algebraic expression 3aq plus at minus 3bq minus bt, and our work is to factorize this algebraic expression. So first, we'll break this algebraic expression into two main groups. At this point, let's write the first group down. The first group is into bracket 3aq plus 80 bracket closed. Let's write the second group. The second group is negative 3 bq negative bt all into brackets. In between these two groups, we are going to put the plus sign. Now let's factorize the items in the first group. When you pay attention to this group carefully, you realize that the item a is the common factor. So let's put a outside of the bracket and leave the other items within the bracket. So when we factorize this item, we would get a outside of the bracket, then 3q plus t bracket closed. We would now bring our plus sign, then we'll factorize the second group. When you pay attention to the second group, you realize that the item negative b is common, or is the common factor. You have negative b in negative 3bq. You also have negative b in the negative bt. So we would factorize negative b outside of the bracket and leave the other items within the bracket. So when we do this, we would get negative b bracket 3q plus t bracket closed. This can be rewritten as a outside bracket, then 3q plus t bracket closed minus b bracket 3q plus t bracket closed. Let's remember that anytime positive and negative meet like this, usually it is the negative that will be in charge. So that's why we replace the two signs by the negative sign in our next equation. At this point, we have two main terms. The first term is a, then bracket 3q plus t bracket closed. The second term is negative b bracket 3q plus t. And from these two terms, the item into bracket 3q plus t is common to both terms. You find that term in the left term, you find that item in the left term, and you'd also find it in the right term. So we would factorize it out. So let's write it aside. So let's write 3q plus t all in brackets. We would then merge the items outside of the bracket into one factor. So the items outside of the bracket are A, then negative B. So when we merge these two items together into one factor, we would get the A minus the B. Let's look at example 2. And in this example, we've been given the algebraic expression 16mx plus 6my plus 24nx plus 9ny, and our work is to factorize this expression. Can we do that now? So as usual, we'll divide the expression into two groups. So we'll put the first group into one bracket, and when we do this, we would get 16mx plus 6my, all of them in one bracket. We'll do the same for the second group, and that would give us 24nx plus 9ny, all into one bracket. Then in between the two brackets, we would put our plus sign. Remember, always we will need to put the plus sign in between the two brackets. Now let's factorize the items in the first group. When we do this, we would get 2m outside of the bracket. Then within the bracket, we would have 8x plus 3y, bracket closed. Let's write our plus sign. We will then factorize the items in the second group. When we do this, we would get 3n outside of the bracket. Then within the bracket, we would have 8x plus 3y, our bracket closed. At this point, we have two main terms. We have the term on the left side of the algebraic expression and the term on the right side of the algebraic expression, and the two terms are separated by the plus sign. You would also realize that the two terms have something in common, which is the common factor. The item 8x plus 3y, all in bracket. You can find it in the left term, and you can also find it in the right term. So what it means that we can factorize that item out. So let's quickly do that. The items outside of the bracket would also be merged together to form one factor. These items are 2m, and the other item is positive 3n. So when we merge them together, we would get one factor, which is 2m plus 3n, all of them in brackets. What this means is that when we factorize the algebraic expression 16mx plus 6my plus 24nx plus 9ny, we would get the expression all into bracket 8x plus 3y, bracket closed, multiplied by all into bracket 2m plus 3n, bracket closed. Let's look at the third type, the difference of two squares. Let's look at the type 3 questions, and here we are going to talk mainly about differences of two squares. Let's look at the following example. x square minus y square. From this example, you would realize that we have one squared item, in this case the y squared, being subtracted from another squared item, in that case the x squared. So, and I believe you know that another word for subtraction in mathematics is difference. So that is where the name differences of two squares is coming from. One squared item being subtracted from another squared item. Now, how do we factorize differences of two squares? To be able to do this, you simply need to follow these steps. First, take the difference of the two items you are looking at without their squares. In this case, the two items you are looking at are x and y. So the difference between them without their squares would be x minus y, but we put all of them in brackets. You would then multiply that by the sum of those same two items we are looking at. So since the two items we are looking at are x and y, their sum will be x plus y. So all of them into brackets will be multiplied by the x minus y, also all in brackets. So what this means is that when we factorize the difference of two squares, x squared minus y squared, our final answer would be all into bracket x minus y bracket closed times all into bracket x plus y bracket closed. As simple as that. So let's apply this simple principle or concept in solving some examples. Example 1. We have been given the algebraic expression x squared minus 36, and we have been asked to factorize this expression. So let's get it done. To be able to do this, I'll need us to first pay particular attention to the number 36. Let's note that the number 36 is a perfect square. What that means is that you obtain the number 36 by multiplying the number 6 to itself. So 6 times 6 will give us 36. So 36 can also be written as 6 squared. So we are going to rewrite that whole expression, but this time instead of writing 36, we'll replace 36 by its equivalent perfect square, which is 6 squared. When we do this, we would get x squared minus 6 squared. At this point, we have the difference of two perfect squares, or two squares. Now, let's apply the rule of difference of two squares factorization here. So first, the first item for this expression is x, and the second item is the number 6. So we would have to take the difference of the two items, that is the difference of the x and the 6. When we do this, we would get x minus 6 all in brackets. Then we would multiply this by the sum of the same two items. The sum of the two items will be x plus 6. As simple as that. Let's look at example 2. In example 2, you have to factorize the algebraic expression 25y squared minus m squared. Let's do this. First, we'll need to note that the number 25 is a perfect square. You would get the number 25 when 5 multiplies itself. 5 times 5 is 25. So 25 can be written as 5 exponent 2 or 5 squared. So we are going to rewrite that whole math statement, but this time instead of writing 25, we would replace it with 5 squared. When we do this, we would get 5 squared y squared minus m squared. 5 square y square can also be written as all in bracket 5y squared. So we're going to rewrite the expression, and this time we are going to replace the 5 square y square by 5y all squared. Right, so this is what we're going to do. When we do that, we would get 5y all squared minus m squared. And now we have the difference of two perfect squares, or the difference of two squares. The first perfect square is 5y all into bracket squared, and the second perfect square is m squared. So first, the two items 5y and m, we are going to take the difference of the two items. So first we would write 5y minus m all in brackets. Then we would multiply this by the sum of the two items, the sum of the 5y and the m. So multiplied by all in bracket 5y plus m. So that should be our final answer when you factorize the algebraic expression 25y squared minus m squared. Now let's look at type 4 questions. And the type 4 questions are mainly quadratic trinomials. And here we will be looking at how we can factorize quadratic trinomials. To be able to factorize quadratic trinomials, we need to know what they are. First, we'll look at what trinomials are. Then we'll look at what quadratic trinomials are. Trinomials. Trinomials are simply algebraic expressions in 3 terms. As the name suggests, tri means 3. So any algebraic expression in 3 terms is a trinomial. For example, the expression 2x plus 4x plus 6 is a trinomial expression, and it is because it has 3 terms. The first term of this expression is 2x, the second term is positive 4x, and the third term is positive 6. So these 3 terms come together to form this trinomial expression. We now know what trinomial expressions are. Let's look at what quadratic trinomials are. Now, at what point do we say that a trinomial expression is quadratic? Well, a trinomial expression is said to be quadratic if it has one or more of its variables having exponent of up to 2. So, at least one of the variables of the trinomial expression should have the exponent of 2. What this means is that our trinomial expression above is not a quadratic trinomial. The reason being that none of the variables in that expression has the exponent of 2. So that expression above is not a quadratic trinomial. Now let's look at the following trinomial expression. 2x squared plus 4x plus 6. And I believe we know why it is a trinomial expression. Now, this expression also shows that one of the variable x has the exponent of 2. We can therefore say that this expression is a quadratic trinomial. Now let's look at another trinomial expression. 2x cubed plus 4x squared plus 6. In this expression, one of the variables, the x, has exponent of 2. The other x has exponent of 3. Now, because the maximum exponent in this expression is 3, it cannot be considered as a quadratic trinomial. Remember, for an expression to be quadratic, the maximum exponent of the variable should be 2, and only 2. At this point, we know what quadratic trinomials are. So let's look at how we can factorize them. Let's look at our first example under quadratic trinomials. And here we've been given the expression x squared plus 13x plus 42. And our work is to factorize this expression. How do we do this? Now, I'll need us to note that anytime we are given a 3-term quadratic expression such as this, the first step you need to take in order for you to factorize an expression such as this is to convert it into a 4-term quadratic expression. So that's what we are going to do at the first step. But the question is, how do we do this? To be able to do this, let's do a little rough work in our jotter. Remember, this rough work will not be part of the actual work. What we will do in this jotter is this. We would multiply the coefficient of the x square or of the variable square by the constant in the expression. The coefficient of the x square in this case is 1. The constant in this expression is 42. So the 1 times the 42 would give us 42. We would then find two numbers which, when multiplied together, would give us this 42. So let's start by looking at these sets of two numbers which, when multiplied together, would give us the 42. First, 1 times 42 would give us 42. Next, 2 times 21 would also give us 42. Next, 3 times 14 would also give us 42. Next, 6 times 7 would give us 42. Next, negative 1 times negative 42 would also give us 42. Next, negative 2 times negative 21 would also give us 42. Next, negative 3 times negative 14 would give us 42. Then finally, negative 6 times negative 7 would give us 42. We will then ask ourselves, among these pairs of numbers, which of them, which when added together, would give us the coefficient of x? Remember from the question, the coefficient of x is 13. So which of the sets or pairs which when added together would give us 13? When you go through carefully, you'd realize that the only pair that would give us 13 when added together is the 6 times 7. The other pairs will never add up to 13, and I mean positive 13. You would realize that we have negative 6 times negative 7 there. The negative 6 added to negative 7 will give you negative 13. So that we can't also use. We can use the positive 6 and the positive 7 because we are looking for positive 13. So what we are going to do is this. We are going to replace the number 13, which is the coefficient of the x, by the item 6 plus 7. Remember, that doesn't change the equation. Sorry, it doesn't change the expression. 6 plus 7 is the same 13. So all we are doing is we are replacing the number 13 by the sum 6 plus 7. That is all. So when we do this, we are going to get x squared plus, then we'll bring a bracket, we'll write 6 plus the 7 bracket close, then we'll bring the x, the variable x, then plus our 42. At this point, we are going to remove the bracket by expanding the above expression. When we do this, we would get x squared plus 6x plus 7x then plus 42. Remember, we got the 6x because the x outside of the bracket multiply the 6, and we also got the 7x because the x outside of the bracket multiply the 7 within the bracket. So as you can see, we have been able to convert the 3-term expression given to us into a 4-term expression. At this point, we can factorize this expression. So first, we would divide this 4-term expression into 2 main parts. The first part is our x squared plus 6x. Let's put all of them in one bracket. And the second part is our positive 7x plus 42. We are putting all of them in another bracket. And the two parts will be separated by this plus sign. At this point, we'll be factorizing the first part of the expression, that is the x squared plus 6x. When we factorize x squared plus 6x, we would get x outside of the bracket, then we have x plus 6 inside of the bracket. When we are done, we bring our plus sign, then we factorize the second part of the expression, that is the 7x plus 42. When we do that, we would get 7 outside of the bracket, then our x plus 6 will be inside of the bracket. So that's how we can factorize that expression. Now you realize that the item x plus 6 all in bracket is on both the right side and on the left side of the expression. So what it means is that that item is a common factor on both the left side and on the right side of the plus sign. So what we're going to do is this: we'll make the x plus 6 stand alone. So we factorize that 1 2 out, so it will stand alone. So let's write x plus 6. Then the items outside of the bracket too, we are going to put them together into one factor. So the first item out of the bracket is the x, the second out of the bracket is the positive 7. So we'll write x plus 7 as one factor. So our final answer after factorizing the expression given to us is all into bracket x plus 6 bracket closed multiplied by all into bracket x plus 7 bracket closed. And guys, you realize that when you multiply these two together, you get the initial problem presented to us. You can try that then see. Now guys, I'll need you to remember and note that this jota work is not part of the work. It is just the rough work to enable us to do the actual work. So it's something you'd have to do in a jota or on a rough paper, but shouldn't be part of the actual work. So I need you to remember that. Let's look at the next example. Let's look at example 2. In example 2, we have been given the quadratic trinomial x squared plus 11x plus 30, and our work is to factorize this 3-term expression. Guys, as we already know, our first aim is to convert this 3-term expression into a 4-term expression. So first, we would multiply the coefficient of our variable square to our constant. The coefficient of our variable square is 1 and our constant is 30. So 1 times 30 would give us 30. Next, we are going to look for two numbers or two sets of numbers which when multiplied to each other would give us the number 30. First, the number 1 times 30 is 30. Next, the number 2 times 15 is also 30. Next, the number 3 times 10 is also 30. Next, the number 5 times 6 would give us 30. Then we have the number -1 times -30 would also give us 30. Next, the number negative 2 times the number negative 15 would also give us 30. Next, the number negative 3 times the number negative 10 would give us 30. Then finally, the number negative 5 times the number negative 6 would also give us 30. Now, amongst these pairs, which of them would give us the coefficient of x when added together? The coefficient of x is 11, positive 11. So when you go through the pairs, you would realize that the pair 5 and 6 would give us positive 11 when added together. So we are going to rewrite the expression given to us, but this time we are going to replace the 11, that is the coefficient of the x, by 5 plus 6. Remember, 5 plus 6 will still give us 11, so it doesn't really change the expression given to us. So let's do this. When we do this, we would get x squared plus, then all into bracket 5 plus 6, then our x, that's the variable, then plus, then we bring our 30. Now this time we are going to remove our bracket through expansion, and when we do this, we would get x squared plus 5x plus 6x plus 30. We got the 5x by multiplying the 5 within the bracket by the x outside of the bracket, and we also got the 6x by multiplying the 6 within the bracket with the x outside of the bracket. So we've been able to convert the 3-term expression into a 4-term expression. So at this point, we will need to divide it into 2 parts. The first part of the expression is x squared plus 5x. We are putting all of them in one bracket. The second part of the expression is 6x plus 30, and we are also putting all of that in one bracket, and we are going to separate the two with the plus sign or the positive sign. Please remember, we always need to separate the two expressions with plus and only plus signs. At this point, we are going to factorize the two expressions separately. So first factorize x squared plus 5x. When we do that, we would get outside of the bracket x, then within the bracket we would get x plus 5. Let's write our plus sign. Then we'll factorize the 6x plus 30. When we do that, we would also get 6 outside of the bracket, then within the bracket we would have x plus 5, the bracket closed. Now you'd realize that the item x plus 5 all in bracket can be found on both the left and the right side, so that's a common factor, so we have to put that as one factor. So we just write x plus 5 all in bracket as one factor. When we are done, we'll also write the items out of the bracket. We'll put them together as another factor. The items out of the bracket are x and the positive 6. So we'll put them together and we would get x plus 6 as another factor. So the two factors multiplying themselves. So that will be our final answer. It will be x plus 5 all in brackets times x plus 6 all in brackets. As simple as that. Let's look at example 3. Let's look at example 3. And in example 3, we have been given the quadratic trinomial 5y squared minus 2y minus 3. And we are to factorize this expression. As you already know, our first aim is to rewrite this 3-term expression into a 4-term expression. And to be able to do this, the first thing we need to do is to multiply the coefficients of the y square by the constant. The constant here is -3. So -3 multiplied by the 5 would give us -15. Next, we are going to look for two numbers which, when multiplied together, would give us this -15. So first, the number -1 multiplied by +15 will give us -15. Next, the number -3 when multiplied by +5 would also give us -15. Next, the number 1 when multiplied by the number -15 would also give us -15. Then finally, the number 3, +3, when multiplied by the number -5 would also give us -15. Now, this time, the coefficient of our y, the variable, is -2. So the question we should be asking ourselves is this: which of these pairs do we have to add together to get the -2? So go through the pairs. When you go through carefully, you would realize that the pairs 3 times -5, when we add the 3 and the -5, we would get -2. So those are the pairs we are going to use to replace our -2. So we are going to rewrite our expression. By this time, we are going to replace our -2 with 3 minus 5. When we do this, we would get 5y squared plus, then we have our brackets 3 minus 5. Remember, 3 minus 5 is -2. Then bracket closed, then our y, then plus our 3. Sorry, minus our 3. At this point, we are going to expand in order to remove the bracket. And when we do this, we are going to get 5y squared plus 3y minus 5y minus 3. So we've been able to convert a 3-term expression into a 4-term expression. So at this point, we'll divide the 4-term expression into 2 parts. So when we divide the expression, we would get this. The first part of the expression is 5y squared plus 3y, and we are putting all of them in one bracket. And the second part of the expression is -5y -3, and we are putting all of that also in one bracket. And as usual, we would separate the two expressions by the plus sign. At this point, we are going to factorize the two groups separately. So we would first factorize the all into bracket 5y squared plus 3y. When we do that, we would get y outside of the bracket, then inside the bracket we would get 5y plus 3, bracket closed. We will then show our plus sign, then we would also factorize the negative 5y minus the 3. When we do that, we would get negative 1 outside of the bracket, then within the bracket we would have 5y plus 3, bracket closed. At this point, you would realize that the common factor on both sides of the expression is 5y plus 3. So we would have to make our 5y plus 3 stand alone. So 5y plus 3. This will be multiplied by all of the items outside of the bracket merged together. The items outside of the bracket are y and negative 1. So we would merge the two together to form one factor. When we do this, we would get all in bracket y minus 1, bracket closed. So that will be our final answer. 5y plus 3 all in bracket multiplied by all in bracket y minus 1, bracket closed. As simple as that. Let's look at the last example. Let's look at example 4. In the example 4, we have been given 4y squared minus 8y plus 3, and we have to factorize this. And as usual, we need to multiply the coefficient of the y squared by the constant. When we do this, we are going to get the number 12, positive 12. Now, so we need to find the factors of the positive 12. Two numbers which when multiplied together would give us 12. Positive 1 times positive 12 would give us positive 12. Next, positive 2 times positive 6 would also give us positive 12. Next, positive 3 times positive 4 would also give us positive 12. Next, negative 1 times negative 12 will give us positive 12. Next, negative 2 times negative 6 would also give us positive 12. Then finally, negative 3 times negative 4 would give us positive 12. Now, from the expression given to us, the coefficient of our variable y is negative 8. So we would go back to the pairs and find out from those pairs which of them would give us the negative 8 when we add them together. When you go through them carefully, you would realize that the pair negative 2 and negative 6 would add up to negative 8. So we are going to choose those two numbers and we are going to use them to replace our negative 8 in the next step. So let's replace the negative 8 in the next step with negative 2 and negative 6. When we do this, we would get 4y squared plus, then all into bracket negative 2 negative 6, our bracket closed. Then we bring our variable y plus the constant 3. So that is it. Remember that negative 2 minus 6 would give negative 8. Now let's expand our expression by removing the bracket. When we do this, we would get 4y squared minus 2y minus 6y then plus 3. So at this point we've been able to convert a 3-term expression into a 4-term expression. So what we're going to do next is to split the 4-term expression into 2 main parts as shown on the screen. So the first part of this expression is 4y squared minus 2y, all of them in one bracket. And the second part of this expression is negative 6y plus 3. We are putting all of them in another bracket. Then the two brackets will be separated by the plus sign. At this point, we are going to factorize the two parts of the expression separately. So first we'll factorize the 4y squared minus 2y, and when we do that we are going to get 2y outside of the bracket. Then inside of the bracket we would have 2y minus 1. Let's bring our plus sign, and we would factorize the second part of the expression, that is negative 6y plus 3. And when we factorize this, we would get negative 3 outside of the bracket, and within the bracket we would have 2y minus 1, bracket closed. Now the common factor on both sides of the expression is the 2y minus 1, all in bracket. So factorize that and separate it, make it stand alone. So let's write that 2y minus 1, all in bracket. This will be multiplied by, so the items outside of the bracket would merge them into one factor. So the items outside of the bracket are 2y and negative 3. So when we merge them into one factor, we are going to get 2y minus 3, all in bracket. So our final answer is all bracket 2y minus 1 bracket close times all bracket 2y minus 3 bracket closed. As simple as that. Well friends, at this point we'll be ending the part 5 of algebraic expressions. In our next meeting we'll be looking at the part 6 of this topic, and under part 6 we'll be looking at how to apply factorization in simplifying algebraic expressions. Thanks very much for staying with us, and please, if you've already not subscribed to this channel, we'll plead with you to do that. Remember, your subscription is necessary for the continuation of this program. Again, once you subscribe and new videos are created, an alert will be sent to you. Thank you very much. Stay safe. We'll meet again in the next class.